hear your voice. Hi. Good afternoon. Thank you for coming. Thank you all for being here at TradEx. I'm happy here that you've made it through the title of the session. That's already a kind of a challenge. I've promised that it will be much shorter the actual presentation. So here I have my partner in crime, Jason Lance. He's our principal member of technical staff at the release engineering team at Salesforceorg. Say hi.
Yeah.
And I am Sebastiano Costanzo. I am an ISV technical evangelist at Salesforceorg. And here we are to talk to you about how to jumpstart your AppExchange product development using Salesforce.org tooling, open source tooling. So first of all, while everybody comes in, I would like to understand how many of you are ISV partners or AppExchange partners or people that want to build an app on the AppExchange more. Yeah, I'm including more people so I get more hands up. Perfect. Yeah, that's the session for you because we're going to help you understand how to build apps for the AppExchange and using the wonderful tools that Salesforce.org gives to our audience, to our developers. And how many of you are familiar with the NPSP, Nonprofit Success Pack, and the higher education architecture? Okay, so we're going to talk about those, but it's not a requirement for you to use the tools. So we're going to be very brief. We're going to give a brief overview of that, and then we're going to go into talking about extending Heda as an example of how to use those tools. And then finally, we're going to look at the details of the tools that are available, and then we're going to go straight into a demo. It will be very hands-on. Yeah, please pay attention on what we do, and if you have any questions in the end, please let us know. So the Nonprofit Success Pack and the higher education architecture are two products that modify in a way the way Salesforce works. Probably it doesn't come as news to you, but it allows basically to create a B2C model in Salesforce, especially for nonprofits and higher education institutions. And they are products built and developed by Salesforce.org, and they're open source, community-driven. They are distributed as managed packages. So actually, Salesforce.org is one of our ISVs that builds applications that are published on the AppExchange. And they are built using the tools that we're going to discuss in detail, Cumulus CI and Meta CI. So what is Heda? It's an app that represents the data architecture of higher education institutions, and it provides this view of a student, its relationships with other people, its connections with accounts, organizations, the courses and the degrees that he's applying to, and it's one single managed package, whereas NPSP is a little bit more complex. It's 6 packages, but we will go into this simple use case, and obviously we will show you, for example, how to build on this architecture and add, for example, on top of the higher education data architecture package, your own packages, like, for example, we have done with Salesforce Advisor Link, like we're going to do with our building blocks for advancement and gift processing. And then, obviously, you can put your package there. And we're going to show you actually how to support the release lifecycle and development lifecycle of your application for the education cloud in this case. But that applies basically, as I said, for any type of package. So are you with us? Are you interested in seeing how, for example, we can extend Heda? And we're going to show that to you using Cumulus CI and Meta CI. Here, I pass it over to Jason.
Yeah, so for the last 4.5 years, my job has pretty much been to make life easier for our developers and for myself, having to run the release operations at Salesforce.org for all of our products. I now have a team of 2 others, so there's 3 of us that work on managing the releases every 2 weeks for our products and push upgrades to over 30,000, or roughly 20 or 30,000 orgs. Don't remember the exact number at the moment. So, but it's a lot, and we do it regularly. And we had to invest heavily in automation of the managed package development process in order to be able to do that. Specifically, we also had to be able to handle extension package scenarios where you have dependencies between packages and automate that as part of our build process. So that led to the creation of Cumulus CI, which kind of at an abstract level is a framework for building portable automation for Salesforce projects. So we built this framework that allows us to kind of plug in tasks and define tasks that are useful across all of our projects. Then we ported over a lot of our kind of build logic into that framework, and that's available now as Cumulus CI. So all the standard stuff that we use in our builds is released as Cumulus CI. So every project that uses Cumulus CI comes with all of that configuration to start. You can also customize that configuration a whole lot per project, and we'll show you a little bit about how you would do that. And it's very tightly integrated with Salesforce DX. And so you can kind of think of it as like an orchestration layer that sits on top of Salesforce DX. So kind of rather than using Bash, you use Cumulus CI to define how you're going to run things. So everything in Cumulus CI for a project is configured through a single YAML file that's in the root of the repo. So if you want to see how we've customized Cumulus CI for our projects, you can go to the Heda and the Cumulus NPSP repository and look at the Cumulus CI YAML and see all the customizations that we do for our builds. And there's one global file that comes with Cumulus CI, and that defines all the standard options, all the tasks, all the flows that make up kind of the whole process. And then each project just defines a Cumulus CI YAML that gets merged on top of that global one and overrides it. So your Cumulus CI YAML is just an override. There's not a bunch of skeleton, cruft in there that you have to put. It's just the stuff that's really relevant to your project. And so the core unit of work is a task, and in the YAML, you can see here it's really simple. It's just mapping to the path of a Python task class. We have a bunch of classes that come with it. You can implement your own, but generally, there's a bunch of logic there, so all that you have to do is define your own tasks in the YAML. You can set options on the task, like the directory that you want to deploy metadata from. And then, if you go on to the next, task can then be sequenced into flows, and so these are named orchestrations. So the most common one is the dev.org flow. This is every project has a dev.org flow that gets a dev.org set up and a scratch org. We have customized and extended for each one of our projects also, or kind of in the process of achieving this dream, to be able to automate loading demo data into the org, mapping layouts in the profile, and basically not only just getting our code into the org, but getting our code into the org to where a QA person could log into it and it's usable. And so that's kind of the goal of it. So. And so the whole overall process that we use, if you look at any of our GitHub repositories, we have a really simple process. There's documentation, there's a whole document about Cumulus CI Flow, which is kind of what I describe our branching model as. So who here is familiar with GitHub Flow? Anyone? Okay. So there's great documentation from GitHub about GitHub Flow, the way that they manage their development. It's really simple. You have a master branch, and the master branch, in our context, is always ready to be packaged. So all development gets done in feature branches, so it's isolated from the master branch and from the package. And then we do pull requests in GitHub, the code review gets done in the pull request, and all QA gets done in the PR before it gets merged to master. So we don't load things together and then QA them, we QA them before we merge them, is the goal of the process. And to facilitate that, we automatically merge every commit on master back into all open feature branches. So every feature branch is effectively an integration branch. It tracks with master plus the feature that's being added. And then we added functionality to make that a little bit easier by supporting parent-child branches. So if you have a bigger feature with multiple developers working on it, you can have like feature rollups, and then feature rollups __ whatever the child branches are for individual components. And then you can do pull requests from those child into the parent and the auto merge will kick off after a build completes and merge back into all the child branches. So, and then the final thing is when we cut releases, we create tags on master of the commits on master that we cut the release from. So it's a really simple branching model. It's worked for all of our products for about 4.5 years now. So.
Great. So, so for the demo, we're going to assume that I am an ISV. I am an ISV developer, and I have built customizations on the higher education architecture package that I mentioned earlier. And with the help of Cumulus CI and JSON, we're going to get and actually build.
Hopefully you don't need me. It should just be Cumulus CI.
Our package. Yeah, well, the demo gods, as they call them. So we're going to go ahead and create a package, upload it, create a release on GitHub, and all these things, and a few more things that we're going to go through. So let's go this is just some numbers. Let's go and start by creating a feature branch, right?
Yeah, so you've got a repository that you've checked out, and there's nothing in this repository really at this point. So the first thing we're going to do is create a feature branch because we don't do any development in master. All development happens in a feature branch. It's a simple git command if you want to create it on the command line. So now we're inside of this new feature branch. And if you run CCI org list, so CCI is the main command line tool of Cumulus CI. It'll tell you, hey, look, you haven't configured the project. Use project init. So you want to go ahead and run that, CCI project init. This is a one-time thing for the project. So this is just creating all the files that are necessary to configure your project. And it's going to go through and prompt you for questions. The first one here, you can accept the default. That's your current folder name, the project name. This should not have spaces in it. Probably need to enforce that in the CLI. But then the package name is going to be the name of the package inside of the org. So we actually do a deployment of an unmanaged package inside the org as a container for the metadata so that we can retrieve it back easier. So this is the name of the package that will be there. It also should be the name of the package in your packaging org if you're doing a managed package.
Okay, so I guess I got the right preset, and this is a managed package I'm creating, right?
Yes, so go ahead and say yes. And so it's going to ask us for the namespace. So you've already created a packaging org with a namespace in it. So
yeah, if I can spell it,
use that. Yes.
Kind of complicated my life.
And we're going to go ahead and accept the current default API version. And then it's going to ask us if we want to extend another Cumulus CI project. So this is a really cool, it's almost like a package manager. You can point at another repository, and it will recursively inherit the dependencies of the other repo. So since our repositories for NPSP and Heda are set up with Cumulus CI, you can inherit your project, you can inherit our dependencies in your project. So if you go ahead and say yes, and we want to extend Heda, so just do one. The option 3 here, you can put your own repo URL. So we just provide defaults for people that want to extend our products. And then we're going to go ahead and accept the standard Git configuration. These are just branch prefix, beta tag prefix, release prefix for what we create in the repository. And all of this is just setting up stuff in the Cumulus CI YAML that you can edit later. So it's just kind of bootstrapping your project. All right, so it's now...
I'm done?
Yeah.
I'm finished?
That looks like it's complete.
Go
ahead and do an ls. All right, so we've got some files that got created. If you go ahead and cat the Cumulus CI YAML, so you can see here it's a pretty lightweight configuration for the project, and that's all the configuration we need to pretty much initialize Cumulus CI for this project. In the dependencies section, you can see we're pointing at the Heda GitHub repository. So go ahead and real quick and run CCI project dependencies. Sorry, this isn't in the script, but I'm going to have it. So what this is going to do is actually interpret our dependencies. So it just went out and inspected the Heda repository, found that 1.51 is the latest release, just created that yesterday, so this project is set up whenever I try to deploy to a Scratch org, it's first going to resolve and install these dependencies to the org before installing my package code. So you automatically inherit all the dependencies of that other project.
Love it.
All right, so let's go ahead and look at CCI org list now that we've got the project configured. So CCI also has a keychain. There's some minor differences to the keychain as far as how it works versus SFDX keychain. One is the keychain in Cumulus CI is project specific. So all the org names here are the orgs for this project. The second is that we have the concept of like lazy scratch org configs. So notice the dev, beta, feature, and release are scratch configs, but there's no username on them. So there's not a scratch org created in those right now. So if you do CCI org info dev, this will actually kind of wake up the lazy configuration, and it goes and creates a scratch org for us. And when it creates the org, it'll then store that org in the keychain under the name dev until we delete it or it expires. So it's kind of a way of having different org configurations that you want to be able to refer to under an easy name, and you just kind of refer to them and don't worry about. So like another thing that's great is it will automatically refresh the scratch org for you if the org is expired and you go to run a command against it.
Jason, a question.
Yeah.
Can you extend this, or do you have to use those names or those orgs?
You can define your own. In fact, if you look at the Cumulus CI YAML, there's a custom org definition. So you can define your own definitions. You can customize the duration days, whether you want the namespace applied, and the URL. The other thing is when we create a scratch org, we set a random password, and that's available in CCI org info. So if you want to connect to IDE tooling and you need the username and password to the org, that's easy right there. And we also set an alias, so you can see the alias TDX18D__dev. So in SFDX, you could just access it through that alias if you know the name of it.
So there's no need to remember password, usernames, and stuff?
Yes, correct.
Great.
Hopefully. All right, so go ahead and...
I think I need to make it the default.
Yeah, so
org.
we're going to go ahead and make the dev org the default, and that's just so that we don't have to specify which org we want to run commands against every time. It'll just use that as the default.
Gets simpler and simpler.
And then go ahead and run CCI Flow Lists. So we saw flows earlier. These are the named orchestrations. And like I said, just having Cumulus CI, you get all of our standard flows available to you. So there's flows available for running feature builds on your CI system, for uploading beta releases, for uploading production releases. But the dev org flow is the one that we want to get working and make sure that that works. So go ahead and do CCI flow run dev_org.
So basically, this is the flow that I am, as a developer, I can run locally, and I can
Yes,
test
and every
my code.
project has this flow. So you can go into any Cumulus CI project, run the dev org flow, and the idea is that the project could customize that flow and add extra things that are necessary to configure that project. But you always know the dev org flow gets you a dev org. And so you can see when the flow kicks off, it's going to spit out the tasks that it's going to run. So all of those are individual Cumulus CI tasks that are available to kind of use in your automations. The deploy is really the kind of key one that's going to deploy the source directory. But the other one is the update dependencies task. And if you scroll down, we should be running now. Cool. So you can see here that it actually went out and inspected the Heda repository, and it's now installing Heda version 1.51 into the org before it's installing any of our package code. So just that one line in the YAML file as a dependency inherits all of the dependencies that we maintain for our own products.
And again, you could use it for any of your projects.
Yes, any other projects. The other thing is you can also use that dependency system to, it doesn't have to point at a Cumulus CI project. You can give it a namespace and a version number, and it can install any managed package at a particular version. You can also give it a zip URL that it can go download metadata, including from a GitHub repository, and then you can give it a subfolder and it will reroute the download. So it'll grab like a subfolder of a GitHub repository and deploy that as unmanaged metadata as a dependency. So there's a lot of flexibility in it.
Yeah, well, this should take another
And of course
30
it's going
seconds.
to. Now, one thing also, just like little things that we invested in to make the user experience of this a lot nicer, you'll notice every 3 polls, we're incrementing the amount of time that we wait in the poll. So you don't wind up, if you have a deploy job that's pending for a really long time like this in a demo, then you don't wind up with 1,000 lines of log messages, one per. Like I just got really sick of seeing those log messages when that happens. So there's a lot of kind of friendly user experience stuff sort of built into the tooling to make it a lot easier and make the build logs look nicer in your build system. Well, so that's going to be pending for a while. All right, well, while that runs, we can go ahead and open up the next tab, or so if you open a new tab, yep.
I'm not sure that I opened the right one. Oops.
No? Should be Apple tab.
Yeah, oh,
There we go.
I need to run CCI though here.
Yeah, so the next thing that we want to do is we can get this dev.org flow running locally, but if we're going to make changes in the project, we want to go ahead and get those changes set up to build in a CI system. And we'll kind of show by example. There's a lot more detail that I could provide about MetaCI, but MetaCI in short is a custom CI system that we wrote to run cumulus CI automation on Heroku, scalable by just spinning up more Heroku dynos. So what we want to do is go ahead and configure MetaCI for this project so that when we do the commit after this first local build works, we'll go ahead and get testing of it.
Yeah, I had it configured in the other. Oh, there you go. Almost done.
Oh, okay, cool. We got past, so. Okay, so you can see here it's actually gone through and it's pulling down unmanaged metadata, so you can see the zip URL and subfolder options in the map that it resolved. And it's installing Heda version 1.51, which is the latest production release of Heda. So you'll note in the dependencies, we didn't specify the version number. So it just, by default, will get the latest production release from the repo. It does that by looking at the GitHub releases through the API. And the latest production release in GitHub releases is what it considers to be the latest release. You can put a tag on there below that and point to a particular tag in the repository if you want to.
Taking a bit longer than 3 minutes.
Yeah, it's finally installing the package. So after it installs the package here, it's going to run the deployment of our code. And in fact, I think this first time that deployment of our code is going to fail because we don't have any code locally. Or do you have a source directory?
No, I do have some. I do have some code.
So if you have a repository that already has a source directory with metadata, like I think tons of people have at least some local folder that has this, it has metadata and a package XML file, you can sort of wrap this stuff on top of that. And the deploy method is by default configured to deploy that source directory for you. So you get all the dependencies, and then it deploys the source directory as your package code. And of course, the demo is going to run slow.
Should I switch to the video I took?
Well, actually, go ahead and cancel this. We do Control-C, so we know that this is going to work, and we'll rebuild it on the CI system. That's more exciting anyhow.
Okay.
So, MetaCI is our CI system, and we have a CLI for that sits on top of Cumulus CI, so it kind of knows all the project configuration you've already given to Cumulus CI and helps you set up your CI system. Jobs in MetaCI are plans. So the MetaCI plan list command will give you a list of the commands that are in your server. There's a MetaCI site add command that will launch a site on Heroku for you. So it's pretty easy to get one of these instances up and running. We've already done that beforehand with this. And in the default system, you get jobs for kind of the main parts of the Cumulus CI flow process, like testing your feature branches, your beta test, your release test. And there's also a container for repositories. So if you do repo list, we'll see that we don't have any repositories configured in the system right now. So we're going to add the local repository. And note, we don't have to tell it what repository we're adding because we're already in Cumulus CI. So it's just asking Cumulus CI, what repository am I in, and adding that repo. So we try to not ask you questions that we should be able to answer just by inspecting what we know about the project. And so the next thing that we want to do is add this repo to the plans that we want to run on this particular repository. So the first one that we want to do is the feature test. And so that just added to plan number 1, which is our feature test plan. Just link this repository to that plan. So now this plan will get feature builds, any commit on a feature branch. So let's go ahead and create a commit on a feature branch then.
I need to first quickly add an org to test it.
Yeah, so any org you connect locally to Cumulus CI, you can toss up to your CI system as well just by this meta CI org add. So it's relatively easy to kind of pass things around. It's okay if there's a typo in the commit message.
Kind of anal.
All right. So you have to cut and paste the first time that you go to push a new branch, the git CLI is really nice and gives you the command to cut and paste. I never remember that option flag. I always could just cut and paste it. All right. So if we look at our build list now, we have a build that kicked off. So the feature plan is running. And we've been looking at this just in the CLI, so let's go look at it actually in the browser. So you can run the browser command on an individual build. So here's our CI system running on Heroku, running the build of the feature commit that we just deployed. And you can see it's extracted the commit into a local repository. This is running in a Heroku worker dyno. So we can spin up as many dynos as we want to for whatever build load we have, shut them down when we want to. We actually use a service called hirefire.io that monitors our build queue and spins up dynos for us automatically. So we can scale up to 99 concurrent scratch.org builds, scale back down, and shut off all the dynos when the build queue goes back down to 0. So Heroku's architecture for this is actually really cool to run CI on. And so you can see here, this is running the CI feature flow. It's created a scratch.org for us, and the output here is the same output that we see from the CLI, because we're running portable automation. The automation's defined in Python. Really, our CLI is just a client to Cumulus CI, a framework for building portable automation. This is another client. It just listens to GitHub webhooks and runs that automation from there. So hopefully that's going to install a little bit faster. It looks like it's going. So we've got this build running out on our CI system. Now, we don't really have, well, actually, I think that's enough, because you've got in the source directory.
Yes, I have some sample code there, so just to configure Cumulus CI. So now the idea is I want to be able to package it.
Yes. So the first thing that we have to do is connect to the packaging org now, because we need to get the packaging org credentials up to our CI system. And we do that with CCI org connect, or actually do packaging. We'll skip the prod retrieve section.
Just do that?
Yeah. Org connect packaging.
Sorry.
All right. So this is forming an OAuth connection to the org. So like the SFDX toolchain or keychain does as well. One thing that's really handy about that, if you didn't know, is that persists through password changes. Which I used to, every 3 months, the password would change or expire in our packaging org and our builds would fail. We don't have that problem anymore. So great, so we now got the packaging org connected. Here in our keychain, it shows up in the list as packaging, a little bit chopped off on the screen, but that's okay. And then we want to go ahead and add that org up to our CI system, so we do meta CI org add. And we're going to tell it the packaging org, the name of the org that we just added, and that transfers up the credentials to our CI system. So our CI system now knows about our packaging org. The other thing that we want to do is actually meta CI. It's not org add. It's we want meta CI plan list.
Sorry, I just wanted to add the beta org as well.
Oh yeah.
Just quickly.
Okay, so you actually don't see it on the screen, but on the left side of this list is the IDs of each one of those plans. So you just do the list, you get the ID of the plan that you want to add, and then, yeah, there we go. And then meta CI plan repo _ add, and we want to add the beta test, which is 3. We want to add the upload beta, which is 2.
Mm-hmm.
Cool, so we just wired up our beta test flows. So whenever there's a commit on master, it's gonna create a beta, install, and then whenever the beta is created, it'll spin up a scratch org, install the beta, run the tests against it. So let's go ahead and merge that PR. Let's see if our build ever completed.
Oh, yeah. What was it here? Okay. Yeah, looks like it did.
Yep. Cool. So we have a successful build. So it just deployed Heda and all the dependencies of Heda into a scratch org that was created by the CI system. CI system deleted the scratch org at the end of the build for us, and then marked in GitHub a commit status. So if we go to GitHub now, and go to your...
I think I need to refresh just quickly.
Yeah, there we go, actually. So it highlights any new recent branches that you pushed and prompts you to create a pull request. So you just go through the standard GitHub process to do that. And in here, go ahead, actually, before you do that, put in the comment hashtag space issues with a capital I, closed with a capital C, and then enter fixes space number 1. You have an issue number 1 in here, right?
Mm-hmm.
Yep, to configure your cumulus CI. Cool. So we actually have, and you can go ahead and save this. I'll show you in a minute how that gets parsed, but we actually have our developers put comments in the release notes that we parse together and then concatenate to generate release notes as part of all the PRs that got merged between 2 tags. We generate the release notes automatically for that. And you can see in this instance, all checks have passed. If you click on show all checks, yep, you can see the feature test here from MetaCI. If you click on details, that'll actually take you over to MetaCI and show you all the build log and everything that happened in it. And so another great thing is you can set up protected branches in your GitHub repository that say, unless that status is green, you're not allowed to click this big green merge button. We have that set up on all of our repositories. So you have to be passing certain builds that we consider to be essential for merge.
So they need to be reviewed by some people?
Well, you can also, in protected branches, set up that there has to be a code review as well by at least one other person than the committer. So we have that set in all of our repositories. It's really nice. Sort of keeps everybody honest. Go ahead and merge this. Cool, so that's merged. It's now in the master branch. And if you go back to to MetaCI, we'll just look at this through the web. All right, so the upload beta plan kicked off. Now this plan runs 2 flows. It runs the CI master flow, which is designed to get your code from the package into the packaging org and delete anything that you deleted from the repository, from the packaging org as well. So you know that what you're about to package is exactly what's in the commit in the repo that you wanted to deploy. And then it's going to run the release beta flow, and the release beta flow uses the package upload request object that's available I believe through the tooling API to upload a package version from the packaging org. And then it creates a release in GitHub. Then it generates the release notes and applies those, puts those in the body of the release in GitHub for you automatically. And then it merges that commit on master into all open feature branches. And what that's going to do is trigger a rebuild of all the feature branches. So every feature branch now gets an integration build with a change that just went into master, which is great if you have a CI system that can support a lot of concurrent builds. So that's part of the reason that we really invested in being able to do that.
In fact, I think I have a few more developers that were creating a bunch of features.
Yeah, I saw that. You have a whole bunch of feature branches sitting out there. So we'll see how your CI system is going to handle. But yeah, we have actually run up to, more as a test, but we've run 99 concurrent builds against scratch orgs through the system, and it worked great. All of the build data, by the way, is stored in Heroku Postgres, because this is just a Django web app that's sitting on Heroku. So we have all of our build history that we can do whatever analysis we want to that's available through standard Postgres tools.
So I guess we get there. We created a package. We created a beta.
Yeah, it looks like it created a package. Now go back to the home real quick. Or you can just click on the MetaCI logo at the top there. All right, so we've got a whole bunch of builds that kicked up. And actually, they're queued. I think you probably still have the Meta CI instance running with a few dynos.
I think on 10, but yeah,
Oh, really?
maybe not.
Refresh it again real quick. Let's see.
You say you have a tool to manage that.
Yeah,
right?
if you go back to the command line, let's go ahead and try it. Meta CI site shape. Do staging. Number of workers 10. All right, so this is going to rebounce our Heroku app. It's possible that the build that was running is not going to recover correctly on this. I'll just warn you, that is one thing that we have to be, we are a little bit careful about when we bounce the Heroku app. There's some parts of it that, but I think actually someone on my team just last week made it where it will restart builds whenever the app starts. So we'll test that out.
Okay, well, I guess this is still running. And yeah, one thing I wanted to show is that we should have a release here. And
yes, if you go under code, release.
So we just released that actually on GitHub.
And you can see here the issues closed. So this is the concatenated release notes content. And if you click on the number 1 there, it also, on all the issues, puts a comment on the issue in the GitHub repository that says what beta release it was included in. And then it will also comment on the production release as well. So we really tried to automate as much of the process. Like we're running such a fast development cycle and release cycle with our products that we have to automate all of this sort of stuff. And all of this is just baked into the tooling that's available to you. So one last thing that's really fun that we can try out is, and this is kind of a good example of how Cumulus CI is kind of constantly evolving. We've been struggling with Selenium testing and API-based kind of integration testing and how to do these sorts of scenarios. And so that's a project that we've recently taken on. And to show you really quickly, if we run this task that's available in Cumulus CI now called Robot, this integrates a Python framework called Robot Framework. Is anybody here familiar with Robot Framework? Cool, yeah. So it's been around for about 10 years. It has a really rich Selenium library, and it's all keyword-based. So you write tests in your keywords, and we are building up a keyword library of how to interact with the standard Salesforce UI, how to interact with the API. Yes, it's being driven completely. So every Cumulus CI project will start with a robot test that will go in and create a contact using a random first name and last name and make sure that you don't break creating a contact. And there's a whole rich library of stuff that you can build on top of that. And each one of these test files is just stored in a .robot file that's just text that says things like go to object home, contact, click object button, new, populate form, first name equals X, last name equals Y, whatever. And so it's really about, and you can see here the kind of CLI output that you get here. So that's run against a scratch org, by the way. So that's the scratch org that we spun up, ran our dev org flow against, and just created a contact in. It also has a bunch of convenient stuff in the library, like deleting the records that you create during the session for you. So you don't have to worry about manually cleaning up all your test data. You just have to make sure those records get registered kind of with the library, but there's keywords to do that. So.
And correct me if I'm wrong here, this is a task, so I can include it in the flow so it can be automated in your
Exactly.
In
if you want to run this on your CI feature flow, so every feature build gets the robot test run against it, you would just add this task to the end of the dev org flow in your cumulusci.yaml.
I just want to show you that's a little bit awkward. Yeah, I won't be able. Now let's see.
And so with this,
that's kind of the output of the
actually
of the tool.
Click on. That's the uglier output. The log rather than report, go to log. Yeah. Mm-hmm. So this, if you click on standard objects, it's a tree structure. So create contacts via API, via UI. If you use the Selenium capture page screenshot, the screenshot gets inlaid in the report right here too. So you can go through and capture screenshots. I have dreams of possibly automating capturing screenshots for documentation this way. We'll see if that works out. But it's a rather new kind of new dimension to Cumulus CI because it allows you to write these rather simple integration tests that go put stuff put metadata in, install or set some data, set some custom settings values, go do some things in the UI, and then check to see what happens. And all of that can be contained just in text in a file. So, yeah, with 23 seconds left, no time for Q&A.
No, I don't think so. Thank you very much. Thank you for the patience.
Yeah, we'll definitely be around if anybody has any questions. We just don't have time for like the formal